Hello everyone, welcome once again to this brand new interaction on triangles class 10th. Remember triangles? We define triangles in many ways till now, right? So if we take three non-collinear points and join them, what we get? This is a triangle. Triangle is the strongest, stablest, two-dimensional structure. Closed figure made up of three line segments is triangle. Or finally, a polygon of three sides is a triangle. On all along we did area of triangles, classification of triangles based upon sides and its angles, right? Its components, its vertex, sides, angles, all that we have done till now, right? So in this chapter, class 10th, what actually we are going to do? Let's take a sneak peek of the chapter first. Now, see, this whole chapter is based on the similarity of triangles. In class 9th, we did congruency of triangles. In this chapter, similarity of triangles will be covered. So we'll build an understanding of similar objects and then move to similarity of polygons. Then we'll do certain theorems in this chapter. First one will be basic proportionality theorem, BPT in short. Thales theorem is another name for the same. Then since similarity is the base of this chapter, so we'll discuss similarity criterias. Angle, side, and side angle, side. Property of right triangles in context of Pythagoras theorem and Pythagoras theorem will be done in this chapter. Question all along the question based on BBT, similarity criteria and Pythagoras theorem, both geometrical and word problems will be solved. Also, we'll do the converse of the theorems in this chapter. So this is a sneak peek, quick sneak peek of the chapter. So let's move further. Okay, now what are the requirements at our end? Means what are the foundations for this chapter? First of all, is language understanding is must, right? Then pattern identification is very important. We'll discuss in brief this thing: pattern identification, decoding of the pattern, polygons and elements, then classification of triangle, correspondence in polygon. It's must see correspondence in polygon and pattern identification. Two things we will discuss in coordination, right? The mensuration area of triangle, basic mentions skills, ratio and proportion, square and square root. So these are the foundation of the skills we need before we move into the chapter, right? Now, first of all, let's since similarity is the base of the chapter, so let's clear this term similar. Similar of the same shape, size may be different, means proportionate dimensions. Objects having proportionate dimensions. See these this picture, these objects are similar. Their shape is same, but size may be different, right? So mathematically, if we talk of similarity of polygons, we'll have to see the angles and sides. Two polygons of same number of sides are similar if the corresponding angles are equal and their corresponding sides are in same ratio or proportion. Then that polygon will be similar. Okay, so as we discussed this correspondence, correspondence in geometry plays a impo important role. Let's see how. So actually what is correspondence is pattern identification, visualization of pattern, and it will help us in understanding the figure and establish the criteria, okay, and decode the congruency and similarity of given polygons, right? Now see, if we are given two triangles ABC and DEF, and correspondence is marked as ABC, DEF, then this means as A is correspondence with B, sorry, D, and B is with E, C is in correspondence with F. Similarly, sides AB, side is AB, DE, BC, EF, AC, DF. So this is how correspondence is established and seen. Let's see one more. In this, correspondence is A, B, C, D, F, E, this way. So when we solve the questions in geometry, correspondence plays a major role. Means if we can identify the correspondence, under which correspondence, which criteria of the similarity or congruency fits, right? Now, similarity of triangles, as we discussed, similarity of polygons, similarity of triangles is the same. Two triangles are said to be similar if their corresponding angles are equal and their corresponding sides are proportional. Then the triangles are similar. Let's understand it with the help of two triangles ABC, PQR. If ABC is similar to PQR, then corresponding angles are equal. A is equal to angle P, angle B is equal to Q, angle C is equal to angle R, and their corresponding sides are in same ratio. AB, PQ. The ratio of AB and PQ is same as the ratio of BC to QR, AC to PR, right? So then these triangles are similar. Okay, now exercise 6.1. The question is fill in the blanks with the correct word given in the brackets. All circles are congruent or similar. Congruency, if we can remember from class 9th, congruency, all the corresponding parts are equal, right? Then the figure is said to be congruent. But all circles, they may have different radii, so they are not congruent, they are similar, right? Similarly, all squares are not congruent. The sides may be of different lengths, right? So they are similar. All triangles are similar. Which one? Isosceles or equilateral? Equilateral triangles are similar, right? In isosceles triangle, angles may be different. Two polygons of same number of this is what we have discussed in previous slides, that corresponding angles are equal and corresponding sides are proportional. So this is the fill in the blanks. And one more question is there. State whether the following quadrilaterals are similar or not. Now see, for polygons to be similar, sides should be proportional, angle should be equal. So in these two quadrilaterals, you see sides are proportional. The ratio is 1:2 or 2:1. Depends, how what quadrilateral we are taking first. But the angles are different. So angles are not equal. Corresponding angles are not equal. So these two quadrilaterals are not similar. Okay. Now let's do an activity. Draw an angle AX. You can do it along or later on by pausing the video. If we draw an angle XAY, right, then mark points PQDRB on AX such that AP is equal to PQ is equal to QD is equal to DR is equal to RB, right? Equal, on equal distance we marks 1, 2, 3, 4 point, 5 points, right? Means A to B, it is divided in equal 5 parts. Then from the last point B, draw a line AY which cuts AY on C, this way, right? And then draw DE parallel to BC, so this BC, we draw a line parallel through point D. How can we draw a line parallel to given line? We just copy the angle, this angle on pointer D, right? Then AD is three parts, right? And DB is equal to 2 parts. So this ratio AD upon DB is 3:2. By construction, and if we measure AE upon EC, you can measure it with your scale. It comes out to be 3/2. So broadly, if we consider ABC as a triangle and DE a line parallel to one of its side BC, then AD upon DB is equal to AE upon EC, right? So is this a coincidence by chance or not? Let's see. So actually, if we want to put the activity in words, we can say that if a line is drawn parallel to one side of a triangle which intersects the other two sides, it will divide the other two sides in the same ratio, right? And this means if ABC is a triangle and DE is drawn parallel to BC such that it intersects AB as well as AC on point D and E respectively, then it will divide AB and AC in same ratio. Means AD upon DB is equal to AE upon EC. So this is a basic proportionality theorem, BPT, Thales theorem. Very important one. We'll prove it in next step. So let's prove it. Now see, basic proportionality theorem, as the statement is that if a line is drawn parallel to one side of a triangle, it divides other two sides in the same ratio. So let's ABC is the triangle and D is the line drawn parallel to one of its sides BC. Then we have to prove that AD upon DB is equal to AE upon EC, right? So first of all, join BE and CD like this and draw perpendiculars from this point E to AD and D to AE this way, EN and DM. Now if we can recall, the area of triangle is given as half into base into height. So area of ADE triangle is equal to half base. If we consider this is base, then this is the height EN, right? Similarly, area of BDE, this triangle. So this is an obtuse triangle, triangle, and if you want to draw the perpendicular or the altitude from this point, this vertex E, it comes out to outside the triangle EN. So area 1/2, BD is the base and height is EN, right? Now if we find out the ratio, means area of ADE upon area of BDE, it comes out to be AD upon DB. This cancels out, EN cancels out. Similarly, area of ADE, now if we consider AE as base, then this DM will be the height, and area of CED, this triangle, also an obtuse triangle, right? For this base, the height is DM. So similarly, the ratio comes out to be AE upon EC. So from these two equations, let's see, left hand side, numerator ADE, numerator ADE, right? Now if we can recall that if two triangles with same base and between two parallel lines, the area will be equal in above two equations. Now see, these two triangles BDE and CED, they are on same base. This is the base and between two parallel lines This line is parallel to this, right? So their area will be same. Now see, in these two equations, numerator is same, denominator now also comes BDE, and area of CED also same. So means left hand side on both the equations are same, which makes right hand side will also be equal, right? So there from this we have that AD upon DB, AD upon DB is equal to AE upon EC. Hence the proof. This was what we are proving, that the parallel line drawn to the one side of a triangle divides other two sides in same ratio, right? This is the proof of the basic proportionality theorem, right? So this is the first exercise and sneak peek of the chapter triangles. What we'll do in next coming videos, we'll discuss the similarity criteria, Pythagoras theorem, converse theorem, and all along we do the questions based on the different criteria and different theorems, right? Second exercise will be on this BPT, basic proportionality theorem only, right? So till then, keep your mindset positive and keep drilling, keep working hard. And don't compare yourself to others. You are unique in your own way. Everybody in this universe is unique, right? Thank you. Thanks for watching.